Okay, this is the next section of our chapter three-dimensional geometry. Okay, the line, okay, straight line in a space. So you have to know what is a straight line. Okay, a straight line in space is uniquely determined if it passes through a given point and a given direction. It passes through 2 points. You know a line. What is a line means? Okay, 2 points have been joined to form a line, and it has a direction. Okay, and two given points has been there and it passes through that points. Okay, so this is the vector and Cartesian equations of line and space have been going to study. Okay, so first is the Cartesian form of a line passing through a given point and a given direction or direction cosines. Okay, direction cosines has been studied in your previous class. So L1, LM, LMN are the direction cosines. Okay, so let A be a point. It is in three-dimensional space, so the point has three dimensions: x1, x1, y1, z1. And LMN be the direction cosines of the line. Then let P, x, y, z be any arbitrary point. Okay, on that line AB. And let AP be R. AP be R. Then let M and N, capital M and N, be the feet of the perpendiculars from A and P respectively on the axis. Okay, these all have been in three-dimensional space, so you have to imagine it. Okay, and then OM, okay, is x1 and ON is x. For easier, you have to just draw these lines. Okay, then you can find MN, that is ON minus OM, that is x minus x1, and MN be the projection of AP on x-axis, and that is R cos alpha. That is, alpha is the angle made by AB on the x makes with the x-axis. So alpha, cos alpha is L, so it is R into cos alpha. And this, look at this, the figure is given here. So that is x minus x1 is R alpha, that is R into L. Okay, so from this figure you will get it very clearly. Like similarly, y minus y1 is Rm and z minus z1 is Rn. Then you can find the ratio. Okay, x1 minus x minus x1 by L and y minus y1 by M, z minus z1 by N. It is the Cartesian form of equation, Cartesian form of the line. Okay, Cartesian form of a line passing through a given point and having given direction cosines. This equation should be remembered. Okay, and some corollary means it has some cases. Yes, if the line passes through the coordinate on the line in terms of a parameter, R is a parameter R, that means the symmetrical form is equal to some R, then what will you get? Okay, that is the first equation. We will equate that equations to R. Then you will get x equal to x1 plus LR, y equals y1 plus MR, and z equals z1 plus NR. Okay, that is then x, y, z, that coordinate, that will you get. So this coefficients x, y, z, the coefficient of x, y, z are unity. That means it is the standard form. Okay, it is the standard form. Okay, and next is symmetrical form of the equation of the straight line when its direction ratios has been given. Okay, that is the second case. Direction ratios has been given. You know A, B, C are the direction ratios. That is you have studied in the previous class. And direction cosines and direction ratios and direction cosines are related by this equation. Then A, B, C. Okay, A, B, C can be substituted by the above equation. That means, okay, that is x minus x1 by A equals y minus y1 by B equals z minus z1 by C. That is the direction ratios. Okay, related to direction ratios, how will you find the symmetrical form? That means the Cartesian form of the line passing through the given point and the direction ratios. Okay, and any point on the line is that it is equated to capital R. In the previous one equated to small r, here capital R. Then you will get the coordinates x, y and z. Okay, and the next one is if x axis and x y z axis pass through the origin, and the direction ratios, you know, it is 1 0 0 0 1 0 and 0 0 1. Yes, we have studied in the previous class. So according to that, what will be the Cartesian equation, Cartesian form? Okay, that is for x axis it is x minus 0 by 1 equal y minus 0 by 1 equal z minus 0 by 1. So x by 1, x for x axis, x is there and y is 0, z is 0. Okay, similarly for y axis and z axis. Okay, so this is the 3 corollaries for, and an equation has been given. Find the equation. Okay, find the direction cosines of a line parallel to this line. Okay, a line is given, you have to find the direction cosines of the line parallel to this line. Okay, and the given equation has been given, you have to write the standard form. Okay, and direction cosines has been given, then find it. Next, the 2-point form. Okay, it is the important one. 2-point form, that is P be any point x, y, z, and x, y, z, which is a point on a line passing through A and B. A is x1, y1, z1 and B is x2, y2, z2. So P be a point on the line AB. Okay, and direction cosines of the line through A and B are proportional to A, B, C direction ratios. And then the equations of the line are x minus x1 by A, y minus y1 by B and z minus z1 by C, that you see in the previous page. Okay, previous. And now you have the direction ratios through A and B, which is proportional to x2 minus x1, y2 minus y1, z2 minus z1. Okay, and then equations passing through A and B are, okay, you have to substitute the A, B and C by x2 minus x1, y2 minus y1, z2 minus z1. So you will get the 2-point form as x minus x1 by x2 minus x1, y minus y1 by y2 minus y1 and z minus z1 by z2 minus z1. This is the important 2-point form. Okay, x, y, z is the point on the line AB. Okay, point on the line AB. A is x1, x2, x1, y1, z1. B is x2, y2, z2. So you have given the points, the line is given, and then the point should be given. This is the 2-point form. Next, the vector form of the equation. Okay, the vector form of the equation of a line. What is the vector form? So in the just before you have studied the Cartesian form, now the vector form. To find the equation of a straight line passing through a point and parallel to a given vector. Okay, that is it is clearly defined there. Okay, so you have given a origin and a point position whose position vector is A. Origin is given and A be the point whose position vector is, and B is the vector, small b is a vector there. AL is the line through the point capital A and parallel to the given vector B, and let P be any point on this line. Okay, so vector B is given, AL is given and P is a point on AL, and AL is a line which is parallel to vector B. Okay, it is clear. Then let R is a position vector. R is a position vector of P. R is a position vector of P. That is, it is from the origin. OP is R. And since vector AP is parallel to B, and we can say it is parallel. Yes, vector AP is lambda vector P. For some lambda, scalar is a lambda. Lambda is a scalar. Okay, that's scalar. Lambda is a scalar for. So you can find AP is parallel to B. So vector AP is lambda B. It is clear, okay? And then vector R. What is vector R? Vector OP. That is vector OP is vector OA, okay, plus vector AP. Vector OP is vector OA plus vector AP. So what is vector OA? Is vector A, and vector OP is vector AP is lambda B. So we get vector A plus lambda vector B is vector R. Okay, so for different values you will get, okay, for changing lambda, if lambda changes, it is a scalar. For different values of lambda, and give different points on this line, and every point on this line satisfies this equation. Okay, yes. And now the required equation of the line is R. Vector R is vector A plus lambda vector B. This is the equation for a line passing through a given point and parallel to a given line. Okay, R is vector R equal to vector A plus lambda vector B. Okay, and if the straight line passes through the origin, that given point is the origin and it is parallel, then yes, vector A becomes 0. Okay, then it is R equal to lambda B. Okay, this is the equation, okay, which is vector form. Okay, very important one, vector form. And two knots has been given, that is equation vector R equal to vector A plus lambda B. There R is the position vector. Yes, position vector has been given for P of n, and therefore R is xi plus yj plus zk. Okay, and the position vector can be taken as lambda A, vector A plus lambda vector B. Next is the vector equation of line passing through two given points. Okay, a given point and a parallel line has been studied. Next is the vector line passing through two given points. Okay, passing through two given points. That is the straight line passing through two given points A and B, x1 y1 z1 and x2 y2 z2. Position vectors A and B. Okay, position vector for capital A is vector A and capital B is vector B, which is referred to the origin. Always position vector is referred from the origin. Okay, and P be any point on this line having position vector R. Then from the figure, okay, look at that figure, where vector AB is the position vector of B minus position vector of A. Vector AB, capital A, B. Okay, and then capital A, AP, vector AP is position vector of P minus position vector of A. That is R minus A. And this, yes, AP is collinear with AB. That is, AP and AB are in the same line. So, they are collinear. Then we can say they are parallel. Yes, AP is equal to lambda AB for a scalar lambda. Then R minus, they substituting that equations. Okay, that is above equations to that equation. Then you will get vector R is equal to vector A plus lambda into vector B minus vector A. That is, R is equal to 1 minus lambda into vector A plus lambda B. Okay, so this is the for two given points, the equation of a line. Okay, yes. And these are some equations these are some knots that has been important for solving equations, solving problems. Okay, to change Cartesian form of equation to vector form and vice versa. That is, changing Cartesian of equation of a line, the Cartesian form to the vector form, and vector form to Cartesian form. How will you change it? So to change Cartesian to vector, the Cartesian equation is x minus x1 by A, y minus y1 by B, and z minus z1 by C. So that is the Cartesian equation of a line you have studied. And then the equation of a line passing through A. A means x1, y1, z1, and having direction ratios A, B, C. We have the vector form of A is the position vector. Vector form of A is the position vector has been taken. That is x1i plus y1j plus z1k. It's the position vector. Then substituting and parallel to the vector AI plus bj plus ck. that is studied. That is the vector form is R is equal to x1i plus y1j plus z1k plus lambda into ai plus bj plus ck, where lambda is a parameter, that means it's a scalar. Okay, so the first equation is the Cartesian equation, second equation is the vector equation. Okay, this is how will you change it. I think all of you understood. That is that a, b, c has been changed to, yes, vector ai plus bj plus ck. So you have changed that equation. x1, y1, z1 is a point A, and that point A, and equation of the line passing through that point and the direction ratios a, b, c is, in the vector form it means, yes, it is the line passing through A whose position vector is x1, y1, z1. Okay, position vector is x1i, that coordinate is x1, y1, z1, that is the change. That point, that coordinate become the position vector, and that direction ratios become the vector which is parallel. Okay, that is the vector form. And next is the vector to Cartesian. So vector form we know R is equal to a plus lambda m. Okay, where a is the position vector of that point and m is the vector parallel to, and lambda is the parameter. Then by vice versa we can yes, change it. Then we have to put, to reduce it in the Cartesian form, you have to put R is equal to xi plus yj plus zk and equate that coefficients of ijk, that coefficients of ijk are the points. So x, y, z. Okay, that is as described as, that is putting R is equal to xi plus yj plus zk, and vector A is equal to x1i plus y1j plus z1k. Then m is equal to ai plus bj plus ck. So we get xi plus yj plus zk is equal to, you have to put these equations on the first equation, substitute. In part of R you have to substitute that xi plus yj plus zk. A x1i plus y1j plus z1k, m ai plus bj plus ck. Then you have to equate the coefficients of x, I, j and k. Then we get x is equal to x1 plus lambda a, y is equal to y1 plus lambda b, z is equal to z1 plus lambda c. Then the lambda is common, so we can, yes, we can write it as x minus x1 by a is equal to y minus y1 by b is equal to z minus z minus z1 by c, which is equal to lambda. So this is how will you convert vector to Cartesian. Okay, yes, examples has been given for you. Yes, and the line passes through the point in another example. Okay, Cartesian form and in a vector form you can find it. And exercises, please do these exercises. Okay, yes, so this is the vector equations, main points for the vector equation. Thank you, students.